So let's delve into what switches really do here. So we have a multi-port bridge running ASICs chips, now called a switch. It's a high port density device, and the port density really depends on what you're doing. If the switch is being deployed to connect to end users, it's best that we have a medium level port density. Usually I don't suggest, if we're going to connect to users, that we have anything above, say, 50 ports. Now I do realize there's some switches out there that'll do 500 ports, but that may not necessarily be a great idea unless you can afford the level of redundancy inside the chassis to make sure it's resilient enough. For instance, things like dual supervisor modules and redundant router engines inside that switch, so that if the supervisor module needs to be taken down because, well, we need to upgrade the code, we don't have to tell 500 users that they can't use the network today. Or at least for the next hour or so. So from a port density perspective, you have to be cognizant of the possible issues you might be facing as far as the overall deployment of these boxes. So I generally suggest, if you want to go the low-end route, a fewer number of ports on a per switch basis, and then the higher-end switches used to aggregate those later on. And we'll talk about some switch design stuff towards the end of this particular section. All right, so we're able to handle large frame buffers with our switches. We have, a huge variation of different types of switches, and then compatibility issues with them, depending on, which vendor you're plugging into. But for the most part, if they're all following the standards here with respect to IEEE Ethernet, we shouldn't have too much of a problem with interconnecting to different devices. Fast internal switching is designed to, on a per port basis, give each individual user the capability of running at the speed Ethernet was designed for. For instance, if you've got a 10 megabit port on your switch, that user should be able to run 20 megabits per second. Now, I didn't make a mistake there. I really mean 20 megabits per second, not 10. Because if it's a switch and you've only got one station plugged into that port, that user can turn off some of the things we needed in Ethernet so I could transmit and receive at the same time, at the full theoretical speed of Ethernet. So if it's a 10 meg port, I can transmit at 10 meg and receive at 10 meg, giving me an overall speed of 20 megabit. Now I can't send up 20 megabit or receive at 20 megabit, but I can do 10 up and 10 down. And that holds true if we go up to fast Ethernet, 100 up and 100 down, or gigabit Ethernet, which doesn't even have the option of running in the mode where we would share it. So it's 1,000 up and 1,000 down.